By mounting a radar on a satellite, we can image the Earth's surface during the day, night, and even through clouds and rain. This technique, called Synthetic Aperture Radar, or in short SAR, produces intricate images like this one of the Eiffel Tower in Paris. We can take images using different wavelengths. Each wavelength falls in a so-called band, with rather peculiar names, such as P, L, S, C, X, Q, K, and K. Each band corresponds to a particular wavelength interval, ranging from decimeters to centimeters and even millimeters. But what kind of images do these bands produce and why? Let's start out with the bands that contain the longest wavelengths, called the P and L band. These long waves can travel further through materials than short ones. For example, they can penetrate dry sands to discover subsurface structures such as caves or ancient riverbeds. They can also travel through tree canopies or reflect on the branches of trees, which is useful for measuring biomass and to measure the movement of the ground in vegetated areas over time. This is one of the few P-band SAR images published just this year by the European Space Agency ESA, which shows the biomass in Amazon rainforests with wetlands appearing in purple and forest covers appearing in green. Now let's move on to shorter wavelengths like the S-band, the C-band, and also the very popular X-band. Now these bands are very good at imaging human-made structures, for example houses, and structures made out of metal, such as cars. In addition, they provide images with high resolution, since in synthetic aperture radar, the resolution in azimuth or in flight direction is directly proportional to the wavelength, meaning that shorter wavelengths produce higher resolutions. The only other variable is the change in the integration angle, which is the change in the angle at which we look at a particular area during imaging. You might notice that the distance to the area we are imaging does not influence resolution at all. And this is actually one of the key differences between optical imaging and SAR imaging. In this X-band image of a Tesla factory in Nevada, we can see the cars on the parking lot as bright tiny spots. Now let's look at the high-frequency bands, starting with the K-bands. We also have the Q-band or K-under with the slightly longer wavelength, and the Ka or K-above band with the highest overall frequency. Electromagnetic waves from these bands interact with water molecules. Because of this, they can be used to measure the movement of ice sheets with a technique called Synthetic Aperture Radar altimetry. We can also use these bands to measure atmospheric precipitation and, during good weather, the vibration of small objects. Or we just use them to get high-resolution imagery, like this 10 cm resolution image, where we can even see the shadows of single branches. And also the cars parked in the parking lot in incredible detail. To really see the difference between the bands, let's compare SAR images with the S, L, and P band taken of the same area around similar times. All images depict an airport in western Greenland and are taken by an airborne SAR by the German Aerospace Center DLR. In the S-band image, we see the airport on the upper right corner. On the left-hand side, we see a large snow-covered area with clear tracks of some snow vehicle. The S-band has a rather short wavelength so that it reflects on the snow surface. The longer wavelength L-band only shows parts of the tracks because it penetrates deeper into the snow. With the even longer wavelength P-band, we don't see the tracks at all. Instead, we see subsurface rivers because the P-band signals just travel through the snow cover. Now returning back to our table, you might wonder why the bands have such complicated names. And why don't we name them according to something simpler like the letters of the alphabet? To understand the names of the SAR bands, we have to go back a bit in history. Modern-day radar was developed during the Second World War, and to prevent espionage, many nations gave cryptic names to the radar bands. The modern-day names mostly trace back to Germany, the UK, and US. This naming convention can also be called the IEEE radar bands, and with a little bit of context, the band names are actually not hard to remember. The P-band was first used by the British, but then later abandoned, so it stands for experimental, or for previous. The L and S band have the simplest explanations, where L stands for long and S stands for short. The X-band was popular during World War II because it was used to lock onto targets. The symbol X kinda looks like a crosshair and was used for the name of the band. You might have noticed that we skipped one band between the X-band and the S-band, which is the C-band. This band is just a compromise between the X and S-band. Last up, we have the K-band, which might come from the German word kurz for short, because this band was mostly used by the Germans. Below, we have the Q or K underband. And with the highest overall frequency, we have the Ka band or K above. If you would like to learn more about synthetic aperture radar, make sure to like, comment, and subscribe.